Hi, in this video we're going to focus on the AmbiFlow 3D ICNIRP tool, and we're going to see why 3D is essential to solving ICNIRP at the earliest stage possible and in real time. In a few moments we're going to run through options in the event of an ICNIRP issue, because although it's great to reveal the problems clearly, what's really needed is to be able to solve those problems quickly and early. That means real time, and we're really going to see the benefit here of doing this in 3D. And at the earliest stage possible, by which we mean to have the option to run desktop assessment before even going to site. The same 3D viewer we see here allows for rapid desktop assessment, where you simply drag and drop the required scenario very quickly and run the tools. In this video we're assessing a new macro site that has been digitized, because this gives us a more powerful use case here. At the end of this video, we'll share another longer video where we go into detail to explain how this digital twin was produced. In the second video, you will see a different design, and that shows the power of the tool to quickly drag and drop different scenarios which can be easily evaluated and compared. Now, the ICNIRP tool serves as a great example of the power of digitalization, which is simply to leverage digitized assets. Because we have a highly accurate 3D digital twin, it means you can leverage more tools and extract even more value and benefit. And there are many benefits of this approach. A few highlights are the automated CAD export, automated inventories, automated bill of materials, and here as we're going to focus on automated ICNIRP. And how the tool works is that once you have dragged and dropped the design, the ICNIRP tool dispatches the design parameters, runs the calculation and delivers the result back into the scene. And for the calculation, customers have two principal options. One is to use the AmbiFlow calculation for the ICNIRP, in which case the tool will fetch all of the antenna positions, all of the power and the other parameters, dispatch all that information into the tool and generate these two surfaces, the occupational and public, into the scene. The other option, which we see here, is to use the customer calculator, and in this case the customer is using a generic solution. The problem with this generic solution is that it's a worst case scenario, one size fits all, and that yields a much larger shape, which appears to show a problem. And we wanted to use this generic shape here because we want to see how the tool works and how we see problems, and of course how we solve those problems. So we're completely using that particular shape. So to take a closer look, I'm going to turn off the public zone first of all and start with the smaller shape, the occupational zone. And what I'm going to do first of all is to turn on the other sectors, and as you can see I've isolated one sector. I'm just going to turn those back off again so we can focus on one. While we're here, let's take a quick moment to see the full 3D scene. So you can see here we've got a full slice of the earth, and we'll explain that in greater detail in the second video that I'll share at the end. I'm just going to drop back down onto the rooftop here, and as you can see, the way this tool works and the way you assess is extremely easy and experiential, because all we have to do is go inside the occupational zone. And what we're looking for is, where does the building protrude into or puncture the 3D surface? And we're seeing here very clearly there's just a tiny portion of the building protruding into that space. If we just come back out of here, we can see very clearly that the worker here is entirely protected inside this frame. This portion of the building is inaccessible, so we can see immediately that this is clearly a pass in terms of occupational zone, because there's no accessible portions of the building inside that zone. So what we're going to do now is turn on the public zone and turn off the occupational. And here we can see, as we go back inside, we can see problems. We've got large portions of the buildings that are protruding into the public exclusion space. And so the question now is what to do. Before we do that, we're going to turn on the magic bubbles, which are a key feature in the digital twin approach, and more about those in the second video. Here we can see what the equipment can see. So let's adjust the transparency slider and look at those buildings that are protruding into the public space, so we get a better understanding before we look at any of the solutions. So we're just right now trying to understand that and see that in fact these are buildings that are clearly habitable. And so therefore, according to this analysis, we have a problem, we have a fail. So the question then is, what can we do? And again, bear in mind, we're looking at this example, which is a worst case example, and in an exact position or a situation, a real situation, the propagation shape here would be much smaller, and therefore might have a pass, for those on those particular shapes. So we select the antenna and adjust the orientation, which is one of the things we can do, and there are a number of other mitigations. So things we can do to look at are maybe the power assessment. We can look at the tilts. We can look at optimizing the power, maybe removing old technologies, for example. We can change the antenna type and adjust the height. And in a new build situation, we can look at an entirely different scheme, one that maybe will solve the problem. So we can look here, we can get a powerful example of just moving the antenna, or the antenna orientations. We can see here that as we pan this antenna and we pull back out, we can see from above, we can see that adjusting the antenna is changing the scene, but it's not actually solving the problem, because we've just got more buildings which are coming into the shape. So again, the size of the shape here is causing the problem, and this is a powerful illustration because we, as I said earlier, we wanted to have a shape that actually revealed problems. But you can see here that as we do, we get the effect. And so that's really it for this video. If you'd like to learn more about the tool and maybe arrange a demo, please contact ray.henry@ambiflow.com. And here now you can see the video playlist and also the URL for the second video. So until the next time, thank you.